All right. So it sounds like you've got this rock blasting exam coming up,
Yeah.
and it's a big one. It
Oh,
covers like everything
it does.
from the like really nitty gritty details about explosives to the
Mhm.
the strategy and design
Yeah,
of a blast.
absolutely.
So we're going to do a deep dive today on the source material that you sent over
Okay.
and really tackle the fundamentals of rock blasting.
Sounds good.
So we're going to cover things like the different types of explosives,
Mhm.
how they detonate,
Huh?
some key properties that you need to know to ace that exam.
Oh, right.
So really
Yeah.
laying the foundation here.
It's like building a house. You
Yeah.
gotta have a strong foundation before you start putting up walls,
Absolutely.
you know?
So let's start with the basics.
Okay.
What exactly is an explosive?
Right.
The source material dives into the chemistry of it,
Yeah.
talking about oxidizers and fuels.
Mhm.
What's going on there?
So
It's not just lighting a match, right?
definitely not. Think of it as a chemical reaction on overdrive.
Oh,
So you've got your oxidizers like ammonium nitrate
hmm,
providing the oxygen,
okay.
and then you've got your fuels,
Right.
often hydrocarbons like diesel,
Hmm.
eager to burn.
Uh-huh.
Mix them, right?
Yeah.
And boom, you release a massive amount of energy,
Right.
the kind that can move mountains
Yeah. Yeah.
or at least some seriously big rocks.
That's what we're after.
Right.
Huh.
Okay.
Okay, that
Yeah.
makes sense.
Okay.
But the source material also mentions two types of explosives,
Mm-hmm.
molecular and compound.
Right.
What's the difference there?
You got it.
Okay.
Molecular explosives like TNT
Yeah.
are like those all-in-one meal kits.
Hmm.
Everything's pre-mixed within the molecule itself.
Right.
Compound explosives, on the other hand,
Okay.
keep the oxidizer and fuel separate
So they're not
until the moment of truth when they're triggered to react.
okay.
It's like mixing the ingredients right before you bake a cake.
The reaction happens when you need it.
So it's all about timing then.
Yeah.
Speaking of reactions,
Hmm.
the source material talks about these different types of combustion.
Right.
I mean, we've all seen a campfire,
Sure.
but how does that compare to what happens when we're talking rock blasting?
Well, campfires are all about simple combustion.
Okay.
It's slow and steady,
Yeah.
releasing heat and light.
Mm-hmm.
But when we talk about explosives,
Okay.
we're stepping into the world of accelerated combustion,
Right.
where things happen a lot faster.
Things are
And
moving and grooving.
exactly.
The source material talks about deflagration and detonation. Is
Yeah.
that like the balloon popping
Yeah,
versus the rocket launching into space?
that's a perfect way to put it.
Uh-huh. Okay.
Deflagration, like in gunpowder,
Yeah.
is a rapid burning,
Hmm.
creates a pushing force,
Okay.
but it's still relatively slow compared to detonation.
Right.
Detonation is the supersonic shockwave, the
Okay.
kind that makes rock blasting possible.
Think of it like the difference between a gentle breeze and a sonic boom.
Oh, wow. Okay, so detonation is the real powerhouse here.
It is.
But I'm curious,
Yeah.
is there ever a time when you might actually want that slower burn,
Yeah.
that deflagration
Uh-huh.
in a controlled blast?
There are actually situations where a slower, controlled release of energy is preferable.
Like when?
Imagine you're working on a demolition project
Mm,
where you need to break down a structure carefully.
right.
Or maybe you're in a mining operation where excessive vibrations
Yeah.
could damage nearby tunnels.
Ah,
In those cases, a slower burn might be the way to go.
interesting.
Yeah,
So it's really about choosing the right tool for the job.
absolutely.
Okay, let's break down detonation itself.
Okay.
The source material says it happens in three phases.
Right.
It sounds kind of like a chain reaction.
It is, think of it like a domino effect.
Okay.
First, you have initiation,
Yeah.
where an external energy source, like a detonator,
Mm.
triggers the explosive.
Right.
Then comes the transition phase,
Oh, yeah.
where things really start to accelerate.
All right. So it's like ramping up.
Yeah.
Yeah.
The reaction speeds up dramatically,
Hmm.
building towards that final powerful release,
And that final release is the boom.
the detonation itself.
Yeah. The detonation, the moment when all that energy
Exactly.
is
It's
unleashed.
like that chain reaction reaching its peak,
Mm.
creating a supersonic shockwave
Okay.
that propagates through the explosive material.
Right.
That's what shatters the rock.
So for our listener who's prepping for this exam,
Right.
it's important to understand not just these phases,
Mm-hmm.
but also the specific properties
Yeah.
that make each explosive unique.
Uh-huh.
The source material dives into a whole bunch of
It does.
these like power,
Yeah.
velocity of detonation, sensitivity.
Right.
Is it almost like we're comparing the stats of different athletes?
Absolutely. Just like athletes have different strengths and weaknesses.
Yeah.
Explosives have different properties
Hmm.
that make them suitable for different tasks.
Okay.
Power, for example,
Right.
tells you how much work an explosive can do.
Okay.
Think of it like measuring how much weight an athlete can lift.
Yeah.
Like,
Get it.
yeah.
And then there's this velocity of detonation,
Uh-huh.
or VOD,
Hmm.
which is how fast that shockwave is traveling.
Yeah. Essentially, how fast that shockwave travels through the
So, like
explosives.
the speed of
Yeah.
a sprinter versus a marathon runner.
Exactly. A high VO
Yeah.
means a faster, more brisant explosive,
Okay.
which is great for shattering rock.
And the source material even has an equation for calculating the pressure
It does.
of detonation,
Yes.
which I guess is related to that velocity and density.
It is.
Seeing that equation really drives home just how much force is generated.
It's mind-boggling how much pressure
Yeah.
those shockwaves can create.
Wow.
And density plays a role too.
Okay.
A denser explosive packs more punch per unit volume.
So that's like,
Think of it like comparing a heavyweight boxer to a featherweight.
yeah, heavyweight
Right.
packs a bigger punch. Then
Exactly.
you have sensitivity,
Uh-huh.
which is how easily it can be initiated.
Exactly. You don't want an explosive that goes off at the slightest bump.
Right.
It's like comparing a calm and collected athlete to one who gets easily rattled under pressure.
Uh-huh. Yeah. You want something that's
Rough.
reliable, but not too hair trigger.
Absolutely.
And then finally, there's water resistance,
Right.
which I imagine is pretty important.
Absolutely.
The
In
thing.
certain environments.
Some explosives are like sponges.
Oh, really?
They soak up water and become useless.
Oh, wow.
Others are designed to withstand even the wettest conditions.
Right.
It's another factor to consider.
So you got to know your environment.
Yeah.
The source material also mentions this critical diameter.
Uh-huh.
Well, what is that?
That's the minimum size.
Okay.
An explosive needs to have to detonate properly.
Mm-hmm.
Below that size, it might just fizzle out.
Oh, wow. So
Look,
it's like imagine trying to light a fire with a twig that's too thin.
yeah, it just won't.
Right.
It needs a certain amount of
You need enough fuel.
fuel to get going.
Yeah.
Okay, that makes sense.
All right.
Speaking of explosive history,
Right.
I was really fascinated by that
Yeah.
story of nitroglycerin.
Right.
The source material talks about how dangerous
Yeah, it was like the wild child of explosives.
it was to handle.
Incredibly powerful, but notoriously unstable.
It's amazing that anyone was brave enough to work with that stuff.
Right. Yeah.
Luckily, we had Alfred Nobel who came along
Yes.
and figured out how to stabilize it by creating dynamite.
Nobel's invention was a game changer.
Okay.
Dynamite took nitroglycerin, that unpredictable force of nature,
Hmm.
and turned it into a manageable tool.
All right. So it's like dynamite tamed that wild child
It did.
and put it to work.
Put it to work safely.
Yeah.
Yes.
The source material even talks about how the proportion
Right.
of nitroglycerin in dynamite affects its blasting properties.
That's right.
So the more nitroglycerin,
More nitroglycerin means more power,
yeah.
but also more sensitivity.
Oh, so it's like finding that sweet spot.
It's like finding that sweet spot between a powerful engine and reliable brakes.
Yeah. Okay.
Right.
So we've kind of covered the basics of explosives themselves.
Hmm.
Now let's move on to the tools that set them off.
Okay.
Detonators.
Right.
The source material mentions everything from simple safety fuses
Yeah.
to these super high-tech electronic detonators.
Hmm.
What's the difference between all these things?
Think of detonators as the trigger
Yeah.
that starts the chain reaction.
Okay.
Safety fuses are the classic,
Right.
reliable choice.
Yeah.
They burn at a controlled rate,
Mhm.
giving you time to get to a safe distance.
So it's like the countdown
It is.
before the rocket launch.
Yeah,
You know exactly when things are going to happen.
you got it.
But what if you need something faster?
That's where detonating cord comes in.
Okay.
It transmits the detonation wave almost instantly. It's like sending a signal at the speed of light.
And then there's these electric and non-electric detonators,
Uh,
which I guess offer even more precise control
They do.
over the timing of the blast.
Yeah, they offer more precise control over the timing of the
The
blast.
source material breaks down like the structure of a non-L shock tube
Hmm.
and how it uses that HMX explosive
Right.
to transmit that detonation wave.
It's amazing how much technology goes into these seemingly simple devices.
Yeah,
Yeah.
it is.
Yeah.
And for someone studying for their exam,
Mhm.
understanding these different types of detonators,
Uh-huh.
how they work,
Yeah.
the components
Right.
is super important.
Knowing your detonators is key to designing a successful and safe blast.
Okay, but Before we get ahead of ourselves with detonators,
Yeah.
let's not forget about that first step in any blasting operation,
Right.
drilling those holes.
Drilling is like creating the foundation for your blast.
Yeah.
You need those holes to place the explosives strategically.
And the source material gives a great overview
It
of
does.
all the different drilling methods.
Hmm.
It's not just grabbing a hammer and chisel anymore, is it?
Definitely not.
Mhm. Mm.
There are two main categories:
Okay.
percussive drilling, which uses a hammering action to break the rock,
Mhm.
and rotary drilling, which relies on rotating bits
Okay.
to grind away at the rock.
The source material uses some great analogies
It
for
does.
explaining all this stuff.
Yeah.
It describes down the hole, or DTH drilling,
Huh.
as like a giant jackhammer.
Yeah, like a giant jackhammer.
Auger drilling like a giant corkscrew.
A giant corkscrew,
And core drilling
which extracts a sample of rock.
as like a biopsy for the earth.
Those are great ways to visualize those different
Yeah,
techniques.
it really helps.
Right.
And just like with the explosives,
Uh,
choosing the right drilling method
yeah,
depends on the rock
absolutely.
and the size and depth of the holes.
Exactly.
The source material even has some detailed
And
diagrams
they're
of some common drilling equipment.
Yeah, they're like blueprints for a successful drilling operation.
Yeah, awesome.
Yeah,
So we've drilled the holes now.
right.
Let's move on to the strategic part,
Yeah.
blast design.
Blast design is the art of arranging explosives and detonators
Okay.
in a specific pattern to break the rock
Hmm.
in a controlled and predictable way.
So it's not just
It's
random,
like a carefully choreographed dance of energy.
placing explosives.
Exactly. Yeah.
And the source material introduces a whole bunch of terms
Hmm.
that are important for understanding this:
Yeah,
burden, spacing, stemming, subdrilling.
you got it.
What are all of those?
Burden is the distance
Oh, yeah.
between the blast holes and the exposed rock face.
Okay.
Spacing is the distance between the holes in a row.
Hmm.
Stemming is the inert material that fills the top of the borehole.
Okay.
And subdrilling is extending the hole below the desired excavation level.
Wow. So there's like a lot to keep track of.
It is, but understanding these parameters is essential for
Yay.
controlling the direction and intensity of the blast.
It sounds pretty complicated.
It can be,
Uh-huh.
but it's also really fascinating.
I bet it is.
Yeah,
The source material even provides formulas and models
it's
for
certainly.
calculating these things.
Yeah, like those developed by Konya Pierce and Rustan.
So there's a lot of math and physics
There
that
is.
goes into blasting.
Those formulas are like the secret recipes for successful blasts.
Okay.
They help ensure that the explosives are placed and timed correctly
Mhm.
to achieve optimal fragmentation
Right.
and minimize damage to the surrounding rock.
So it's not just brute force, it's also about
It's about precision and control.
precision and control.
Absolutely.
And that's where, I guess, controlled blasting techniques come into play. The
Exactly.
source material goes into detail about techniques
It
like
does.
line drilling,
Uh-huh.
crisp splitting,
Mhm.
smooth blasting,
Yeah.
cushion blasting.
Right.
Like it's a whole arsenal
Think of it as a sculptor's toolkit.
of tools for shaping these blasts.
You have different techniques for chiseling away at the rock,
Wow.
each one designed to create a specific shape or effect.
Okay.
Line drilling, for example, is like scoring a line in the rock
Hmm.
to create a clean break,
Yeah.
while pre-splitting
Okay.
creates a predefined fracture plane
All right.
to protect the surrounding rock.
So it's like a more
Yeah, it's a more controlled
controlled approach.
approach.
Yeah.
Yeah,
And then smooth blasting. I'm guessing that's about
that's right.
creating that nice, even finish
Smooth blasting is all about achieving a smooth final wall.
on the rock face.
Yeah, it's like using a finer chisel to create a smooth and precise cut.
And then cushion blasting is like,
Cushion blasting is all about using decoupled or spaced charges
okay,
to minimize overbreak and damage to the surrounding rock.
gotcha.
Yeah.
So it's a delicate balance then
And yeah,
between power and finesse.
exactly. And for your exam, understanding these controlled blasting techniques, their advantages and disadvantages is crucial.
Okay. So we've covered a lot of ground here.
We have.
Explored the types of explosives, how they detonate, the
Yeah.
tools we use to set them off,
Right.
his art of blast design,
Uh-huh.
and these techniques for shaping these blasts.
And the techniques. Yeah,
It's a lot to take in,
it is.
but it's clear that rock blasting is,
It's a fascinating field that combines a deep understanding of physics and chemistry
yeah,
with the practical skills of engineering and construction.
it's both a science and an art.
Absolutely. It is a lot to take in.
It really is a lot.
Yeah.
And for anyone prepping for an exam,
Mm.
It's not just about, like,
Mhm.
understanding these concepts, it's also
And I know how to apply it.
knowing how to
Yeah.
apply them.
In the real world.
Yeah, in a real-world scenario.
Exactly.
Speaking of applications,
Yeah.
we were talking about those tests for measuring explosive power,
Uh-huh.
Trousel and Hess.
Right?
The source material goes into some detail
It
about how those tests actually work.
Yeah.
Can you give us the, like, lab coat version?
Okay, imagine you're a scientist with a lead block and a tiny but powerful explosive.
Okay.
That's essentially the Trousel test.
Right.
You drill a hole in the lead,
Mhm.
carefully place a 10-gram sample of the explosive,
Right.
and then detonate it.
Uh,
The size of the cavity created in the lead block
mhm.
tells you how powerful that explosive is.
Oh, so it's like
Wise.
the bigger the dent, the more powerful the blast.
It's like comparing how big of a dent
Yeah.
different explosives can make.
Okay. What about the Hess test?
The Hess test uses a steel cylinder instead of lead
Okay.
and a bigger sample of explosive,
So it's like a more
100 grams.
intense test?
Yeah, it's like testing those explosives on a tougher opponent.
Right.
This test is particularly useful
Okay.
for evaluating those heavy hitters used in large scale blasting.
So both of those tests are about measuring
Raw power.
that raw power.
Yeah.
Okay.
Mm.
What about controlling that power
Okay.
within a borehole?
Right.
The source material mentions linear charge density.
Uh huh.
What is that?
So linear charge density is like packing a suitcase for a trip.
Okay.
You want to fit as much as possible without going over the weight limit.
Yeah.
In blasting, it's about how much explosive you pack
Hmm.
into a certain length of the borehole.
Okay.
Too little, and you might not break enough rock.
Right.
Too much, and you risk excessive vibrations or even a misfire.
So it's a balancing act.
It is a balancing act.
The source material even provides an equation
It
for
does.
calculating
No,
that.
it's all about precision.
All about precision. Okay.
Yeah.
Now let's talk about ANFO.
Okay.
What makes it so special?
ANFO is like the reliable workhorse of the blasting world.
Okay.
It's relatively cheap, safe to handle, and incredibly effective.
That's a good combo.
Right.
Yeah.
But remember those ammonium nitrate prills?
Uh-huh.
The tiny beads that make up ANFO? Need to be just the right size
Okay.
for optimal detonation.
What size are we talking?
The source material says the sweet spot is between 1 and 2 millimeters in diameter.
So those prills are like Goldilocks.
Yeah.
Not too big, not too small,
Not too big, not too small,
but just right.
but just right.
Why is that size so important?
It's about maximizing the surface area for the fuel oil
Mm,
to mix with the ammonium nitrate.
okay.
If the prills are too big,
Yeah.
the fuel doesn't have enough surface area to react effectively. If
Okay.
they're too small,
Right.
they pack too tightly, reducing the airspace needed for good detonation.
So they got to be
So those prills
perfectly
need to be
sized.
perfectly sized little fuel sponges.
Huh. Okay.
Yeah,
The source material also has these fascinating tables
it does.
showing the energy and emissions
Yeah.
of different ANFO mixtures.
Right.
It's almost like we're comparing the
Exactly.
fuel efficiency of different cars.
Those tables highlight the trade-offs
Okay.
involved in choosing an ANFO mix. More fuel oil typically means more power,
Right.
but it can also increase the amount of harmful gases
Right. So it's
released during the blast.
balancing act again.
It is a balancing act.
Okay.
Yeah.
Now remember, ANFO's weakness
Yeah.
is water.
Yes.
The source material dives into a couple of solutions,
It does.
emulsions
Uh-huh.
and heavy ANFO.
Right.
What's the difference?
Emulsions are like ANFO's water-resistant cousin. They're designed to work even in wet boreholes.
All right, so they're like ANFO in a raincoat.
Think of them as ANFO in a raincoat.
Uh-huh.
They're a bit more complex to make,
Yeah.
but they offer superior water resistance
Uh-huh.
and often better performance overall.
What about heavy ANFO?
Heavy ANFO combines the affordability of ANFO
Okay.
with some of the performance benefits of emulsions.
So it's like getting,
Puree,
you essentially mix ANFO with some emulsion
the best of both worlds.
to increase its density and power.
Okay, cool.
Yeah. Now let's take like a detour back into the history books for a second.
Okay.
We touched on nitroglycerin and dynamite,
Yeah,
but the source material really paints a picture
it does.
of just how dangerous nitroglycerin was
It was like playing with fire, literally.
to handle.
Their source material describes how even the slightest shock, friction, or temperature change
Wow.
could set it off.
It's no wonder it had a reputation for being so volatile.
All right.
Yeah.
Yeah.
Amazing that Alfred Nobel not only works with it,
Right.
but figured out how to tame it.
He did. He was a brilliant guy.
Yeah.
Yeah.
His invention of dynamite really changed the game.
Dynamite took nitroglycerin, that unpredictable force of nature,
Mhm.
and turned it into a manageable tool
So dynamite put a safety leash
It did.
on nitroglycerin
Yeah,
and made it so much safer
much safer.
to work with.
Yeah.
The source material even explains how the proportion of nitroglycerin
Right.
in dynamite affects its properties.
That's a key point for understanding how to choose the right dynamite.
Okay?
Higher nitroglycerin content means a more powerful blast,
Right.
but it also increases the sensitivity.
Right. So again, it's that sweet spot.
It's all about finding that sweet spot between power and controllability.
Yeah. Hmm? Okay.
Yeah.
Let's move on to those tiny but mighty triggers,
Okay.
detonators. The
Detonator.
source material goes beyond just like
It does.
listing the types.
Yeah.
It gets into the inner workings of
Right.
these fascinating devices.
They are fascinating.
Yeah.
Yeah.
So starting with the classic safety fuse,
Yeah. The safety fuse.
how does that work?
It's essentially a precisely timed burn. The source material explains how it's basically a fuse on a firework.
Yeah.
You light it, and it burns down to the explosive charge at a controlled rate, giving you
Mm.
time to get clear.
But what if you need speed?
Then it's detonating cord time.
Okay.
It transmits the detonation wave much faster.
All right. So it's like
Like an express train compared to a local.
express train versus the local.
Yes.
Okay.
The source material even describes how the multiple layers of material in the cord
Mm-hmm.
ensure strength, flexibility, and waterproofing.
Wow. It's amazing how much engineering goes into something that seems so simple.
It really is.
Yeah. And then we have electric detonators,
Hmm.
which use an electrical current to set off the charge.
Electric detonators offer more precise control over the timing of the blast.
Okay.
The source material even breaks down the different components of an electric detonator,
Mm-hmm.
explaining how each part contributes to initiating a controlled detonation.
So it's like a tiny but intricate circuit
It is
designed to trigger a powerful reaction.
a very powerful reaction.
What about non-electric detonators?
Non electric detonators rely on a shock wave to
Okay.
trigger the explosion.
Okay.
The source material describes a type that uses a shock tube
Mm-hmm.
filled with a sensitive explosive called HMX.
Okay.
When the shock tube is initiated, the HMX detonates,
Mm.
creating a shock wave that travels through the tube to the detonator,
Right.
setting off the main explosive charge.
So it's like
It's
this
like a chain reaction of explosions,
chain reaction.
all perfectly timed.
Wow.
Yeah,
The source material even includes a diagram
it does.
showing the structure of that Nunell shock tube.
Yeah, it's incredible how much technology is packed into these devices.
It really is.
Right.
Yeah.
Yeah.
And for someone studying for their blasting exam,
Mm-hmm.
understanding these different types of detonators
Uh-huh.
and their delay mechanisms
Right.
is really important for knowing how to control
Yeah, it's like conducting an orchestra of explosions.
that sequence
You got to get the timing just right.
of explosions. Yeah.
Yeah.
Wow. Okay.
Yeah.
Now let's not forget about those rock stars of modern blasting,
Okay.
electronic detonator.
Electronic detonators.
The source material highlights systems like the Orica Icon the 9
Hmm.
and the eDev 2it.
Right.
They sound incredibly sophisticated.
They are. Electronic detonators offer an unparalleled level of control and precision.
Oh, wow.
They allow blasters to program complex firing sequences,
Huh.
test each detonator individually,
Wow.
and even monitor the entire blast in real time.
The source material even talks about how you can control
It
it does kind
does.
of the timing
Yeah, you can control the timing down to the millisecond.
down to the millisecond.
It's like having a digital timer for each individual explosion.
That's amazing.
It is
And
amazing.
I'm guessing that level of control
Yeah, that level of control is crucial
is super important.
for optimizing fragmentation,
Hmm.
minimizing vibrations,
Right.
and ensuring the safety of the operation.
It all comes back to safety.
It always comes back to safety.
Okay, but before we get carried away
Right.
with detonators,
Yeah.
let's remember that first and often overlooked
Yeah, the first
step in any glassing operation,
rock drilling.
rock drilling.
Yeah.
The source material goes beyond just mentioning drilling.
It does.
It gets into the different methods used.
Yeah.
It's not just hammering away at the rock anymore.
Right. There are two main categories.
Okay.
Percussive drilling, which uses a hammering action to break the rock,
Mm-hmm.
and rotary drilling, which uses rotating bits to grind away at the rock.
And the source material explains the difference between
It does.
down the hole or DTH drilling, where the
Right.
hammer is like down in the borehole,
Hmm.
versus top hammer drilling,
Right.
where the hammer is at the surface.
Correct.
How do you choose?
It depends on the type of rock and the desired size and depth of the holes.
Okay.
DTH drilling is often used for larger diameter holes
Hmm.
and harder rock formations,
Okay.
while top hammer drilling is suitable for smaller holes and softer rock.
And then you have rotary drilling,
Right.
which is like a giant drill bit.
Yeah, it's like using a giant drill bit to carve through the rock.
Yeah.
The source material explains that there are different types of rotary drilling,
Hmm.
each suited for different rock conditions.
Like what?
There's tricone drilling,
Sorry.
which uses a bit with 3 rotating cones to crush the rock,
Okay.
and drag bit drilling,
All right.
which uses a bit with fixed cutters that scrape away at the rock face.
It's amazing all these different techniques
It
for
is.
doing this.
Yeah,
The source material even has diagrams
it does.
of common drilling equipment.
Yeah, those diagrams are a great resource for visualizing how those complex machines work.
Yeah.
Yeah,
But once those holes are drilled,
right.
it's time to move on to that strategic part
Yeah, the strategic part of blasting.
of blasting blast design.
Blast design is like creating a blueprint
Okay.
for a controlled demolition.
Right.
It's about strategically placing explosives and detonators
Hmm.
to achieve a specific outcome.
Okay. And the
Yeah,
source material introduces those
right.
crucial blast design parameters:
It does.
burden spacing, stemming, and subdrilling.
Yes, those are the key ingredients
Yeah.
in a successful blast
Do
design.
you remind us what those are and why they're so important?
Burden is the distance between the blast holes and the free face,
Hmm.
the exposed rock surface.
Okay.
It determines how much rock each explosive charge has to push against.
Okay.
Spacing is the distance between holes in a row,
Right.
which affects how the explosive energy is distributed.
Hmm.
Stemming is that inert material at the top of the hole that
Yeah.
confines the explosive gases,
Okay.
like putting a lid on a pressure cooker.
Right.
And subdrilling is extending the hole deeper than the desired excavation level,
Okay.
which helps ensure that the entire rock mass is fractured.
So those are all super important for controlling
They are.
that blast.
Yeah, understanding those parameters is essential
Okay.
for controlling the direction and intensity of the blast.
The source material even walks us through these various formulas and models used to
Yes.
calculate these things.
Yes, those formulas and models are like the secret weapons of a blasting expert.
Okay.
They help predict how a blast will behave
Hmm.
and allow for adjustments. Right.
To achieve the desired fragmentation, minimize vibrations, and control the direction of the blast.
So there's a lot of
There's a lot of science
yeah,
and engineering
science and engineering
that goes into blasting.
that goes into this.
It's not just about brute force, it's about precision
Yeah.
and control.
Yeah. Okay.
Yeah.
And that's where I guess those
That's where those controlled blasting techniques come in.
controlled blasting technique.
Line drilling and pre-splitting
Yeah.
come into play.
So they're all about
They're all about minimizing damage to the surrounding rock
mhm.
and achieving precise excavation boundaries.
Okay, and line drilling is like
Line drilling is like scoring a piece of glass before you break it.
mhm.
You create a line of weakness in the rock
Right.
to help it break cleanly along that line.
Pre-splitting is like
Pre-splitting is like creating a protective barrier
yeah.
around the blast area.
Okay.
You drill a row of lightly charged holes along the excavation boundary
Mhm.
and detonate them before the main blast.
This creates a predefined fracture plane
Yeah.
that helps contain the explosive energy from the main blast.
So it's like,
Think of it as building a fence to protect the surrounding rock
yeah, like a
from the shockwave.
protective barrier.
Exactly.
Okay. And for
Yeah.
achieving that, like smooth
Right, for a smooth final wall.
final wall.
There's smooth blasting,
Okay.
which uses closely spaced, lightly charged holes
Mhm.
detonated with precise timing to create a smooth and even break.
So it's like using a scalpel
It is.
instead of a hammer.
It's like using a scalpel instead of a hammer to shape the rock.
Yeah.
Yeah.
Okay.
And then there's cushion blasting,
Right.
which is all about using decoupled or spaced charges
Hmm.
to reduce the amount of explosive energy transferred to the rock,
Okay.
minimizing damage and overbreak.
So it's a gentler
It's a gentler
approach.
yeah.
Okay. So all of those controlled blasting techniques are about
They're all about finesse and precision.
finesse and precision.
Absolutely.
Yeah. Now let's talk about how that rock actually breaks.
Oh,
Rock fragmentation.
rock fragmentation.
The source material describes
It does.
3 main stages:
Yes.
radial fracturing,
Uh-huh.
forward movement,
Mm-hmm.
and final fragmentation.
Think of it as a 3-act play.
Okay, like,
Tact 1, radial fracturing.
yeah.
The shockwave from the explosion creates radial cracks in the rock,
Okay.
like spokes radiating out from the center of a wheel.
Okay.
Then comes Act 2, forward movement.
All right.
This is where the rock starts to break free.
Okay.
The expanding explosive gases push the rock outward from the free phase.
Mm-hmm.
The timing of this movement is crucial.
Okay, why is that?
If it happens too soon, the explosive energy might be wasted.
Okay.
Too late, and the rock might be over-confined,
Right.
creating excessive vibrations.
So the timing has to be
The timing has to be just right.
just right.
Yeah.
And then the grand finale,
Act 3, final fragmentation.
final fragmentation.
This is where the rock breaks apart into smaller pieces.
Okay.
The combination of the expanding gases,
Yeah.
the reflected shock wave, and those radial fractures
Mm-hmm.
work together to break the rock into a manageable size.
So understanding those stages
Understanding those stages of
is
fragmentation
really important.
is crucial for designing effective blasts.
Okay.
It's about harnessing the power of explosives
Right.
in a controlled and predictable way.
And the source material also highlights this topic.
It does.
Drill hole deviation,
Drill hole deviation.
which can be a real headache for blasters.
It can be.
What is that?
Drill hole deviation is the tendency for the drill hole to stray from its intended path.
So it's like you're aiming for one spot
It is.
and it ends up somewhere else.
It's like trying to hit a moving target.
Yeah.
It's a common challenge, especially when drilling deep holes or working with complex geology.
And the source material, I think, even has a diagram
It does.
showing how like the length of the hole and the type
Mhm.
of drilling equipment can affect that.
That's a great way to visualize the problem.
Yeah.
Longer holes are more prone to deviation,
Okay.
and certain types of drilling equipment can exacerbate the issue.
So you got to choose your equipment carefully.
You do.
Now let's talk about
Yeah.
con optimization.
Cost optimization.
Blasting can be expensive.
It can be.
So how do you keep those costs?
Cost optimization is a balancing act.
Yeah.
You need to find the most efficient way to achieve your blasting goals
Okay.
without sacrificing safety or quality.
And the source material breaks down drilling costs
It does.
in all these categories.
Right. It breaks it down into labor, equipment, consumables, and energy.
And it gives some practical tips
And it does.
for reducing those costs.
Yes, like optimizing drilling parameters,
Mm-hmm.
using high quality drill bits to minimize wear and tear,
Okay.
and choosing the right drilling equipment for the job.
So it's all about efficiency.
It's all about efficiency.
Now let's dive back into
Okay.
the heart of blast design. Calculating those crucial parameters
Yeah.
like burden spacing and stemming.
Those calculations are like the recipe for a successful blast.
Cool.
Get them wrong.
Yeah.
And you risk poor fragment, excessive vibrations, or even a misfire.
The stakes are high.
The stakes are high.
The source material goes really deep
It does.
into this topic,
Yeah.
explaining all these different formulas and models.
Right. It explains different formulas and models used by blasting experts.
Yeah.
From simpler formulas that relate burden to borehole diameter
Mm.
to more complex models that consider factors like explosive rock density and rock strength.
So it's like
It's like the difference between baking a simple cake and creating a gourmet masterpiece.
yeah, simple versus
Or
complex.
those advanced models allow for a higher level of precision,
Right.
but they also require a deeper understanding of the science behind blasting.
And the source material, I think, even provides
It does.
examples
Yeah, it provides examples of how to apply those formulas,
of how to apply it.
which is incredibly helpful for seeing how they work in practice.
But it also highlights the fact that
Right.
these calculations
These calculations are not always straightforward.
aren't always straightforward.
Determining all the factors that go into those calculations can be challenging.
Yeah.
That's why blast design is both an art and a science.
Okay.
You need a solid understanding of the
Oh.
theory, but you also need the experience and judgment to apply that theory in the real world,
Right.
where conditions are rarely ideal.
Yeah, it's not a textbook
Exactly.
scenario out there.
It's not.
Okay.
No.
The source material also has this section on borehole diameter.
Right.
It seems like such a simple thing.
Yeah.
Why is that so important?
Borehole diameter is like choosing the right size pan for a recipe.
Okay.
It can significantly impact the overall effectiveness and cost of the blast.
How so?
A smaller diameter hole might be cheaper to drill,
Okay.
but it might limit the amount of explosive you can use, affecting fragmentation. And a larger diameter hole might allow for more explosive, but could increase drilling costs
Yeah.
and potentially lead to more vibrations.
That's just about finding that sweet spot.
Finding that sweet spot.
Yeah, between cost effectiveness,
Right.
fragmentation control, and environmental impact.
Okay.
Yeah.
Now let's revisit pre-splitting.
Okay.
The source material really dives into the
Okay.
benefits and challenges
Yeah.
of this method for achieving those like
For achieving those clean and stable excavation walls.
clean and stable
Yeah.
excavation walls.
Pre-splitting is a powerful technique for creating those picture-perfect excavation walls.
Okay.
It involves drilling a row of closely spaced holes along the desired excavation line,
Mm-hmm.
lightly charging those holes,
Okay.
and detonating them before the main blast.
So it's like you're
It's like creating a perforated line,
yeah,
making it easier for the rock to break cleanly along that line.
right.
The source material emphasizes the importance
Okay.
of creating a tensile fracture in the rock.
Okay. Rather than a crushing or shattering effect.
So it's not about,
It's like peeling a banana.
yeah,
You want a clean separation.
a clean separation.
Yeah, okay.
And I think the source material even has diagrams
It does.
showing like the ideal
It's just the ideal spacing and charging techniques for pre-splitting.
spacing and charging.
Yeah,
Okay. But it also points out that pre-splitting
right.
can be a little tricky.
Pre-splitting can be tricky.
Yeah.
It requires precise drilling,
Mhm.
careful charging,
Okay.
and accurate timing to ensure that fracture forms correctly.
Hope so.
It's a technique that demands a high level of skill and attention to detail,
Not for the faint of heart.
not for the faint of heart.
Okay, let's talk about stemming again. You
Yeah,
mentioned it before,
yeah,
but the source material really highlights
it does.
how important it is
Yeah.
to get that stemming length.
Stemming length is like adjusting the seasoning in a recipe.
Oh,
Too little, and you might end up with a bland blast.
all right. So not enough.
Not enough confinement of the gases,
Huh?
leading to fly rock air blast and noise.
And too much.
And too much stemming can be like oversalting the dish.
Right.
It can reduce fragmentation and increase vibrations.
So it's about finding that right balance.
It's about finding that right balance again.
And luckily, the source material provides
Yes.
a table.
It provides a table showing the recommended stemming length
Oh, wow.
for different borehole diameters.
That's super useful.
It is like having a cheat sheet for stemming,
Yeah.
but it also mentions different stemming materials.
Well, does it matter what material you use?
It does. Different materials have different densities and particle sizes,
Okay.
which can affect how well they can find those explosive gases.
Right. So it's like
It's like choosing the right type of lid for your pressure cooker.
the right lid.
Yeah.
Okay.
And for those looking for an extra layer of stemming security,
Yeah.
the source material introduces the concept of stemming retainers.
What are those?
Stemming retainers are like those little clips that keep your chip bag closed
Okay.
and prevent the stemming from being blown out of the borehole too early.
So they're like extra insurance
They are.
that stemming is going to stay put.
Exactly.
The source material even describes
It's
different types of stemming retainers.
right, like those that use expanding materials or mechanical locking mechanisms.
So again, we're seeing that.
It's another example of the continuous innovation happening in the blasting world,
Yeah. The innovating
all aimed at improving safety and efficiency.
in the blasting world.
Yeah.
Now let's circle back
Okay.
to controlled blasting techniques.
Controlled blasting techniques.
We touched on them before,
Yeah.
but the source material gives
It gives a really comprehensive overview
this really comprehensive
of the different options available.
overview of all the different options.
Controlled blasting techniques are essential for minimizing damage to the surrounding rock
Yeah.
and achieving precise excavation boundaries.
And starting with line drilling.
Line drilling is like scoring a line in the rock to create a clean break.
Hmm.
It's a simple but effective technique
Yeah.
for creating a plane of weakness
All right.
that helps control the direction of the fracture.
And then there's pre-splitting.
Pre-splitting, we talked about that earlier.
Yeah, we did.
It's like building a protective barrier around the blast area
Right.
to minimize damage to minimize damage to the surrounding rock.
And for that smooth
Right, and for achieving a smooth and even excavation wall.
excavation wall.
There's smooth blasting,
Hmm.
which uses closely spaced, lightly charged holes with precise timing to create a smooth break.
So it's like using a fine-tooth comb to create a
It is.
perfect line.
It's like using a fine-tooth comb to create a perfectly straight line.
Yeah, okay.
Yeah.
And cushion blasting.
Cushion blasting uses decoupled or spaced charges to minimize overbreak and damage.
Right, so that's more of a gentle,
Yeah, it's often used in situations where you need to avoid shattering the rock into too many small pieces. It's like using a gentle touch to control the fragmentation.
yeah, okay.
The source material even provides diagrams
Tezu.
to illustrate how these different controlled blasting techniques work.
Those visuals are really helpful, I bet,
They are.
for understanding all these different techniques.
Yeah.
Okay.
And for someone prepping for their blasting exam, it's crucial to understand the advantages and disadvantages of each technique and when to use them.
Right. You got to pick the right tool for the job.
Exactly. It's about choosing the right tool for the job based on the specific requirements of each blasting operation.
Now let's talk about explosives themselves.
Okay.
Understanding the different types.
Knowing your explosives is like knowing your ingredients when you're cooking.
Yeah.
You need to understand how they behave and how to combine them to get the desired result.
The source material provides a
Okay.
really helpful overview
Yes.
of those different classifications of explosives.
Right.
And starting with the difference
Yeah, starting with the distinction between high explosives and blasting agents.
between high explosives and
Yeah,
blasting agents.
high explosives are like the sprinters of the blasting world.
Okay.
They detonate quickly, creating a powerful shockwave perfect for shattering rock.
All right.
Yeah.
And the source material lists some familiar ones there.
It does like TNT, gelatins, and dynamites.
Yeah.
Those are the classics.
Those are like the
Explosives that have been used for decades in all sorts of blasting
oh
operations.
geez.
Right.
Uh-huh.
Yeah.
And then we have blasting agents,
Right.
which are more like the marathon runners.
Yeah, they're designed to be less sensitive and more economical.
Yeah. Right.
And the most common blasting agent is ANFO.
Right. And that's the workhorse of the industry.
Yeah, it
But
is.
it's got that water vulnerability.
It does. If ANFO gets wet, it's pretty much game over.
Yeah.
That's where emulsions come in, like we discussed earlier.
Right.
They're designed to withstand wet conditions.
Yeah.
Yeah.
The source material has this table
Stuff.
summarizing
Yeah, it's a great resource for comparing and contrasting different explosives.
the properties of
Yes.
all these different explosives.
It lists their sensitivity, velocity of detonation, density, and water resistance,
Yeah.
giving you a quick snapshot of their strengths and weaknesses.
So it's like a cheat sheet
It is like a cheat sheet.
for explosives.
Yeah.
But let's dive a little deeper into
Yeah.
some of these
After-
specific types that the
Yes.
source material highlights.
Okay, let's start with dynamites.
Okay.
They were a game changer back in the 1800s
Yeah.
because they offered a safer way to handle nitroglycerin.
Dynamite tamed that wild child.
It did.
And the source material
Right.
breaks down all these different types.
It breaks down the different types of dynamite gelatins, semi-gelatins, and ammonia dynamites,
Yeah.
explaining how their composition affects their properties and water resistance.
So that's super helpful for understanding
Yeah, that breakdown is really helpful.
why one might be chosen
For understanding why blasters choose one type over another for a particular job.
over another.
Yes.
Yeah.
Yeah.
Now let's move on to ANFO,
Okay. ANFO.
the most widely used explosive in the world.
It is the most widely used.
Yeah.
ANFO is simple, reliable, and incredibly cost effective.
Yeah, we touched on that before.
We did, but it's got that water vulnerability.
You're right.
Right.
So you got to be careful with that.
You do.
The source material dives into what
Exactly.
makes ANFO tick.
Yeah, highlighting the importance of using the right size ammonium nitrate prills
Yeah.
and ensuring proper mixing with the fuel oil.
Right. Those drills have to
We
be
do.
just right.
Just the right size.
It even provides tables
It does.
showing the energy
Yeah, it shows the energy and emissions of different ANFO mixtures,
and emissions of different mixture.
which is crucial for understanding how tweaking the recipe can impact both power and environmental impact.
So it's like fine tuning.
It's like fine tuning the recipe
Yeah.
to get the results you want.
And then for those who need a little extra oomph,
Right. For those who need a little extra power,
there's heavy ANFO.
there's heavy ANFO,
Which is that?
which blends ANFO with emulsions to boost density and punch.
Blend.
Yeah.
Yeah.
Heavy ANFO offers a great balance between affordability and performance.
Yeah.
You get the cost savings of ANFO, but with some of the added performance benefits of emulsions,
Best of both worlds.
kinda, yeah.
And then finally,
And then we have emulsions.
emulsions, ANFOs,
ANFO's water-resistant cousin.
water-resistant cousin.
Yeah, emulsions are a bit more complex than ANFO,
Okay.
but they offer superior water resistance and often better performance overall.
Right.
But as the source material points out, emulsions can be a bit more finicky than ANFO.
Okay. How so?
They require careful handling and placement to ensure they detonate properly.
So you got to treat him with a little more
You
respect.
got to treat them with a little more respect.
Uh-huh. Okay.
Yeah.
It's like blasting has its own set
It
of
definitely does.
rules and best practices.
Okay. And speaking of best practices, the source material dives into a topic that's essential for anyone working with explosives: safety.
Yeah. Safety should always be.
It should always be the top priority.
The top priority, right?
Absolutely. Blasting is a high risk activity, and there's no room for complacency.
Yeah.
The source material doesn't go into specific safety regulations,
Right.
but it stresses the importance of following all applicable rules and guidelines,
Hmm.
using proper personal protective equipment,
Right.
and always working under the supervision of experienced professionals.
So it's a team effort.
It's definitely a team effort.
Yeah.
Yeah.
And everyone needs to be on the same page.
Everyone needs to be on the same page when it comes to safety.
When it comes to safety,
Absolutely.
for our listener who's prepping for their exam,
Mhm.
they need to understand not only like
Right.
how to do all this stuff,
Yeah.
but also the why.
Yeah, the why is
What are
important.
the main goals
That's
of
right.
a successful blast?
The goals of blasting are like the finish line of a race.
Okay.
You want to achieve optimal fragmentation,
Right.
minimize damage to the surrounding rock,
Hmm.
and control the throw of the blasted material,
Okay.
all while ensuring the safety of everyone involved.
So it's like this
It's like a carefully choreographed dance
choreographed dance. Yeah.
where every step has a
And
purpose.
the source material.
It highlights some key factors
Backlights.
that influence the effectiveness of a blast,
Okay.
like the type of explosive used, the design of the blast pattern, and the geology of the rock
There's a
mass.
lot to
It's a lot to consider.
consider. Yeah.
Yeah,
It's not a one size fits all
it's not a one-size-fits-everything.
approach.
No.
I've also noticed that the source material
Mhm.
touches on the environmental impact
It does.
blasting.
Yeah,
Um,
a few times.
what are some of the key
Right.
concerns there?
Blasting, by its very nature, has an impact on the environment.
Yeah,
Some of the main concerns are air overpressure, fly rock, ground vibrations, and noise.
that makes sense.
Those are all things that need to be carefully managed
Right.
to minimize any negative effects.
Yeah.
And the source material emphasizes the importance
Okay.
of implementing mitigation strategies,
Like what?
like using proper blast designs, choosing the right explosives,
Okay.
and monitoring environmental conditions before, during, and after blasting
So it's
operations.
about being aware
It is about being aware
of your surroundings
of your surroundings and the potential impacts of your actions,
and I guess minimizing those.
and minimizing those as much as possible.
Yeah.
It's
Yeah.
about using our knowledge and skills to make informed decisions that minimize our impact on the world around us.
So responsible blasting.
Responsible blasting is finding that balance between achieving our goals and protecting the environment.
Yeah. Okay.
Yeah.
Well, I think we've covered a lot of ground
We have.
in this deep dive.
Yeah, we've explored the science of explosives, the art of blast design, and the importance of safety and environmental responsibility.
For our listener
Yeah,
who's about to take that big exam,
right.
any final words of wisdom?
I would say to focus on understanding the fundamentals,
Okay.
not just memorizing facts and figures.
Mhm.
Blasting is a complex field.
Yeah.
And the more you understand the underlying principles,
Right.
the better equipped you'll be to handle real world challenges.
So it's like understanding the strategy
It's like the difference between learning the rules of a game and truly understanding the strategy behind
of
it.
the game
Yeah.
rather than just learning the
Exactly. And don't be afraid to ask questions
Mm.
and seek guidance from experienced professionals.
Right.
The blasting community is full of knowledgeable people who are willing to share their expertise.
To our listener, best of luck in your exam.
Best of luck.
We're confident you're going to do great.
We are.
Remember, blasting
It's a field that combines science art
is a field that
and a
combines
healthy dose of problem solving.
science, art, and problem solving.
It's a challenging and rewarding field,
Yeah.
and we're excited for you to be a part of it.
That's a wrap for today's deep dive.
Thanks for joining us.
Thanks for listening.